here to learn about cybersecurity, learn things about cybersecurity, to educate ourselves about things also in cybersecurity. So that is what this seminar is all about. We are here to learn about cybersecurity, to learn about how we can protect, how we can um, look at what is happening, how we can get this information and also use this information to help manage our phones, our laptops, so on and so forth. That is all that this seminar is all about. Okay. Now, we will actually look to our first part, where with this particular first part, it is security awareness training. This security awareness training actually involves a video most of the time. This video is animated and we are going to watch a video. So for this particular first session, we'll be watching a video and then we'll be answering questions about this particular video. So I would actually bring up my screen so that we can actually watch this video. And when we are done with this particular video, we'll come back here again and discuss and also answer questions about this particular video. So please don't go anywhere. Just stay attentive to the video. When we are done, all of us will contribute so that we can answer the questions about this particular video. Okay, so let's actually do that.
Ningio, episode 910. I've got your number. Security topic, social engineering. Starring Stacy Keach as the CFO. One of the world's largest telecommunication companies recently disclosed a data breach that exposed phone call and text message records for 110 million people. These records can be used by threat actors to scam victims through sophisticated social engineering attacks. Jungle Prime headquarters, evening. A finance employee walks down the hallway.
James, why is the payroll account zeroed out?
What? It shouldn't be?
The CISO overhears the conversation from her office.
I know it shouldn't be, but it is. Take a look.
How did this happen? Oh no. That call from the bank wasn't really the bank.
What are you talking about?
Well, a call I got a few days ago.
Flashback. A hacker calls James.
Hello, James. My name's Owen with First City National. I'm calling because I've noticed suspicious activity with your corporate account.
Suspicious activity?
That's gotta be it. The caller must have been a threat actor.
Wait, but he called using the bank's correct number.
Probably spoofed. I just hosted a company-wide seminar that went through the key points of this exact hack, James.
Were you not part of the seminar?
No, I was. I guess I was just, daydreaming? I don't know.
Well, here it is again. Hackers use stolen information, such as phone records, to create sophisticated social engineering attacks.
Social engineering is the use of deception to manipulate individuals into divulging confidential or personal information or taking action that may be used for fraudulent purposes.
Correct. Hackers often design their social engineering scams around a target's sense of fear about having their bank account drained. It all starts when cybercriminals get a hold of stolen data, such as phone records or other personal information, by purchasing it on the dark web. They then use the stolen data to learn the details about a victim, like the name of the company they work for, their job title, and what bank they use, all of which helps them carry out their attack.
But they even sent me a one-time password to verify they were talking to me.
The one-time password was fake, fabricated and sent directly to you by the hacker in order to gain your trust, so you would click a link.
And the link they sent must have been for a malicious site. By entering your credentials, you essentially handed them over to the hacker.
Ugh, I can't believe I fell for the scam.
That's why it's called social engineering. You were tricked into doing something you normally wouldn't do. In the future, if you notice an email, call, or text is causing you to have an emotional response, such as fear, take a step back and be extra cautious. Calling a person back using a known trusted number is a good way to verify a call. And always remember, if you're suspicious about a recent interaction through phone, email, or SMS, be proactive and change your passwords for those accounts.
Okay, yes, I'll do that from now on. And, one thing, do you think that, I might lose my job over this?
There's only one way to find out. By breaking the news about all this to the big boss. After you, James.
Teachable takeaways. Hackers have the ability to connect stolen phone records to specific people and companies. They then use this information to initiate sophisticated social engineering attacks that prey on your emotions, such as fear. If a caller is asking you to take sensitive action, hang up and call them back with a known trusted number. If a recent interaction through phone, email, or text message seems suspicious, be proactive by changing your passwords. Ningio, Episode 910. I've Got Your Number. Security topic, social engineering. Starring Stacy Keach as the CFO. One of the world's largest telecommunication companies recently disclosed a data breach that exposed phone call and text message records for 110 million people. These records can be used by threat actors to scam victims through sophisticated social engineering attacks. Jungle Prime headquarters, evening. A finance employee walks down the hallway.
James, why is the payroll account zeroed out?
What? It shouldn't be?
The CISO overhears the conversation from her office.
I know it shouldn't be, but it is. Take a look.
How did this happen? Oh no, that call from the bank wasn't really the bank.
What are you talking about?
Well, a call I got a few days ago.
Flashback. A hacker calls James.
Hello, James. My name's Owen with First City National. I'm calling because I've noticed suspicious activity with your corporate account.
Suspicious activity?
That's gotta be it. The caller must have been a threat actor.
Wait, but he called using the bank's correct number.
Probably spoofed. I just hosted a company-wide seminar that went through the key points of this exact hack, James.
Were you not part of the seminar?
No, I was. I guess I was just, daydreaming? I don't know.
Well, here it is again. Hackers use stolen information, such as phone records, to create sophisticated social engineering attacks.
Social engineering is the use of deception to manipulate individuals into divulging confidential or personal information or taking action that may be used for fraudulent purposes.
Correct. Hackers often design their social engineering scams around a target's sense of fear about having their bank account drained. It all starts when cybercriminals get a hold of stolen data, such as phone records or other personal information, by purchasing it on the dark web. They then use the stolen data to learn the details about a victim, like the name of the company they work for, their job title, and what bank they use, all of which helps them carry out their attack.
But they even sent me a one-time password to verify they were talking to me.
The one-time password was fake, fabricated, and sent directly to you by the hacker in order to gain your trust, so you would click a link.
And the link they sent must have been for a malicious site. By entering your credentials, you essentially handed them over to the hacker.
Ugh, I can't believe I fell for the scam.
That's why it's called social engineering. You were tricked into doing something you normally wouldn't do. In the future, if you notice an email, call, or text is causing you to have an emotional response, such as fear, take a step back and be extra cautious. Calling a person back using a known trusted number is a good way to verify a call. And always remember, if you're suspicious about a recent interaction through phone, email, or SMS, be proactive and change your passwords for those accounts.
Okay, yes, I'll do that from now on. And, one thing, do you think that, I might lose my job over this?
There's only one way to find out. By breaking the news about all this to the big boss. After you, James.
Teachable takeaways. Hackers have the ability to connect stolen phone records to specific people and companies. They then use this information to initiate sophisticated social engineering attacks that prey on your emotions, such as fear. If a caller is asking you to take sensitive action, hang up and call them back with a known trusted number. If a recent interaction through phone, email, or text message seems suspicious, be proactive by changing your passwords.
Okay, so welcome back from this particular video. And after here, we are going to take our quiz. This is about social engineering, where people actually, or hackers actually manipulate us into doing things that we wouldn't want to do or we wouldn't have done at the end of the day. So let's look at the questions. And these questions are based on the video that we just watched. So let's look at the first question. Question number 1. If you know the answer, please unmute yourself and tell us the answer. Or you could also put the answer in the chat section so that we all can see. Okay, if somebody says an answer and you don't agree with the person, you can also tell us your answer and why you think that is the answer. That way we can learn together and we can get to understand these things. Okay. All right, let's look at question number 1. Hackers often design their social engineering scams around a target sense of. So the options are fear, curiosity, boredom, and all of the above. Hackers often design their social engineering scams around a target sense of what? First, fear, curiosity, boredom, or all of the above. What do you think the answer is? Anybody knows what the answer is to question number 1?
I think the answer is fear.
Yeah. Okay.
Yes, please.
All right, sure. All right. We have 2 people who agree with this particular thing. Okay. Let's look at question number 2, also true or false. Social engineering only occurs through emails. True or false? Social engineering only occurs through emails. True or false?
Please, the answer is false.
False. Okay. Social engineering doesn't only occur through emails. This we all agree with. Which of the following is not a tactic used in this attack? Spoofing phone numbers to appear legitimate, encrypting all communications for safety. The third one says sending unsolicited emails or texts. The last one says manipulating their target's emotions. Which of the following is not a tactic used in this attack? where they were spoofing phone numbers to appear legitimate, encrypting all communications for safety, sending unsolicited emails or texts, all of the above, and then manipulating their target's emotions. What do you think the answer is to question number 3?
I think encrypting all communications for safety.
Yeah.
Okay, encrypting all communications for safety. I think we have we have a lot of people who actually agree with this particular one. Let's look at encrypting all communications for safety is the odd one out. Okay, let's look at question number 4. So true or false? Hackers can use stolen phone records to learn about victims' personal details. True or false? Hackers can use stolen phone records to learn about a victim's personal details. True or false?
It's true.
Yeah, that's true. Okay. Okay. Question number 5. What is a good practice when receiving a suspicious phone call asking for sensitive information? So the first one says provide the information immediately to resolve the issue. The second one says call the person back using a known trusted number. The third one says send a text message to confirm the request. The last one says all of the above.
The second one is the answer.
Call the person back using a known trusted number. Okay. All right. Question number 6. That's the last question. Then we'll be done with it. Social engineering attacks rely more on exploiting technical vulnerabilities than on human behavior. So true or false? Social engineering attacks rely more on exploiting technical vulnerabilities than on human behavior. What is the answer? True or false?
It's false.
It's false. Okay, where is the complete quiz? Sometimes it happens like this. All right. Okay. So yes, thank you guys for the submission. I think sometimes it happens like this. You have to refresh everything and watch the video again before that button can come, but that also takes some time. So thank you all guys. Thank you guys for the submission and everything. I believe that by now, if you've been enjoying this particular seminar, you know what social engineering is and you know some basic things to protect yourself when we talk about social engineering. Okay. Now, today, our topic for the seminar, that is what we are done with the first one, we are going to the second part, is let's talk about firewalls. All right. Now, we are going to be talking about firewalls for today. Now, most of us here know what a firewall is, or actually have heard what a firewall is, but then we don't actually know the types, what it does, a little bit of demo about firewall, and that is actually what we are going to be doing today. So, a firewall, what is a firewall in the first place? Well, it is a fire and it is a wall. That's what people will say. Yes, it is one of our first line of. That is what a firewall is. When we talk about a firewall, it's what administrators use a lot. How do we even use this firewall in the first place? Let's talk about that for today. And let's look at certain things that we could talk about firewalls. Okay, so let's come here and I'll do this. Okay. Let's talk about firewalls. Now, when we talk about firewalls, we look at the fact that, well, we are all on the internet, right? But all of us are all on the internet. And then before we even go to the internet, we understand that a network is what? A connection, or a network is where two or more systems, two or more computers can talk to each other or can communicate to each other and share resources. That is a network, right? That has already been established. We also learned that the internet is the network of networks. So we know that the internet is also a network of networks. Now, if the internet is a network of networks, it means that once you connect to this particular network, you get to also share resources with different people, like share resources to your friends on the internet, like that we are all aware of. Now, without that, or when that actually happens, it means that other people too want to also connect to you. Other people too might want to also look at what you're doing, because you are out there and you are sharing resources to people. Somebody too might want to also look at the resources you are sharing. Somebody also out there might also want to find out what you are doing on your systems. And that is what these firewalls are for. Now, without all these things, or without, let's say, protection, a lot of times we are exposed to the internet, and then these threat actors are also on the internet. Now, we have to also know what we allow and what we disallow. Because when we connect to the internet, there are so many things, there are so many activities, there are so many protocols, there are so many things happening on a network or happening on the internet. We have to look at what we allow and what we don't allow. And that actually is where a firewall actually comes in. A firewall is the foundation, or it's part of the foundation of cybersecurity. And it is mostly viewed as the first line of defense when we are protecting our systems and our networks. Now, a firewall is anything, right, or a system that looks at things coming in and out, and then it is able to protect you based on the things that you set. So if you have a computer, the request going in and out of your computer, what you are sharing on the network, in and out. So what you send to a person is going outside. What is coming to you is coming inside to you. So data that moves in and out, right? Now we have to find somebody who is also there to be looking at all those things. Somebody who is also there to be checking and seeing that the data that you are sending out, or the request that you are sending out, is what is actually the one that you said you would, or it is supposed to go to the person that you say it should. And then if it is returning to you by somebody that you know, or it is passing through the right places that you said it should pass through. So data or requests going in and out, some people will call those things egress and then ingress. You see, this is actually a word given to most firewall settings, right? Ingress, it is the traffic coming into your organization, the organization as a whole, or your systems as a whole, or your computers as a whole is what? Ingress. And then egress is the traffic that is leaving your systems to a different system or to a network outside. That is what egress. So in and egress, right? Now, this firewall or a firewall allows you to look at all those things. Now, when we talk about firewalls actually work when you set them up. Firewall is not something that let's say, you buy and then you put it there. No. Firewall looks at rules. So firewall will be like a bouncer in front of a building. And we have actually given some instructions to the bouncer that if somebody is coming inside the building or wants to come inside the building, the person must be dressed formally. The person must wear this or that. The person must have maybe this amount of money with him. This person must be tall or whatever it is. That is what this file will do. So based on the instructions given to this particular bouncer, he or she will allow people to enter based on the rules, the laws that we've given to him or her. And that is how a firewall actually works. Organizations, personal devices want to find out things coming in their organization or things going to their particular computer. If it's something that they are giving or they have allowed, if it is that, it sees that traffic as good. If it is something that they have not allowed, it sees that particular traffic as bad. And then whenever what happens or what activities, this particular firewall also keeps track of all activities, who they've allowed inside the building and who they've bound or who they've blocked. That is what a firewall is all about. So a firewall actually is a security system that looks at things going in and out of a network or a system, and then it is able to monitor them based on rules that we have set. That is that. So what a firewall does, and a firewall will reduce an attack surface. Yes, a firewall would make sure that or would prevent systems from being attacked. Let's say the attack surface or the risk or the probability where an attacker would find ways. Firewall would limit them. So it would limit how an attack happens. Let me say it that way, or it will reduce the attack surface. That means that if there are 100 ways somebody can break in, now firewall has limited those things to, let's say, a 20 or a 50. That is actually reducing the attack surface. Okay. Then we have a firewall can prevent unauthorized access. If you have not given permission to certain people, these people cannot access your network. That's what a firewall actually does. Controls outbound connections. Firewall looks at things going out. The request you are sending out, is it okay? Is it good? Should it go? The firewall will look at all these things and then it would make a decision. Now, firewalls can also detect suspicious behaviors. If there's something going on the network, based on that particular things happening, firewalls can actually detect and say, we don't actually trust these things. They're not like all firewalls, but then there are certain firewalls out there that can detect suspicious behavior, that can look at what people are doing, or can look at some request that is coming in or some things happening and say, no, with this particular thing, we think it is bad. We will not allow this to enter, so we will block it automatically. That is what a firewall can also do. And after everything, firewall can give us the logs where we can investigate further if, let's say, we block somebody or we even allowed somebody. Firewall could give us all the logs, and then we could go ahead and find out more information and find out more about this particular person who wanted to break in, about an activity that actually happened that the firewall actually recorded. You could go further ahead and study it to know whether this thing belongs to an attacker or this IP address belongs to whoever that it is. And that is also one thing that firewall can actually help us with. Now let's move forward. Now, firewalls can be a physical device. So firewall can be a device that you buy and you connect it to your network, and everything passes through that. With that particular one, you have centralized control and you could monitor all traffic going in and out. So firewalls can be a hardware appliance as a network device. Firewalls can also be softwares that are installed on systems. They can be installed on computers. Some mostly operate on the OS level, that operating system level. We also have some that can run as a virtual machine instead of running as a software that we install. It is a software itself, but it runs as an operating system itself, where you have to connect your systems to that. So firewalls for most organizations, they use the hardware appliances for the network or the network devices. And then they also have these softwares installed on their endpoints, their computers. That's also a way in which these firewalls are actually, they come in the kinds of firewalls. it that way. Now, let's look at types. So we have different types of firewall, but then the most important ones that we know of is the stateful firewall and then the next generation firewall. But let me explain all those things, the other types. So packet filtering firewall is just a firewall that looks at packets coming in. It treats individual packets as single. It doesn't combine packets. Whenever somebody is sending something over a network, it is breaking down into small parts called packets. Or this particular firewall check those things and then look at the IP address and in the packets, the port the packet is passing through, the protocol the packet is using, and use that to make a decision. It is fast, but then it is limited in certain way. That is what this packet filtering firewall is all about. It is very fast, but then with this particular packet filtering, it doesn't put everything together. And it would inspect the packet by packet itself, single packets only, right? And it doesn't have a memory to put all this packet together to make a decision. And that is what the packet filtering firewall is all about. The other one, the opposite of that one, is the stateful, where with this particular thing, it tracks all connection. It looks at the packet itself and also put all the packets together as a session wherever this packet is coming from. If this packet is coming from a place where after combining everything, it sees this as bad, the stateful firewall would block this particular thing. So with the stateful firewall, it looks at context, it looks at everything put together, and that is what is that. It is more secure than the packet filtering. And it's also one type of firewall that is the foundation of firewall that most organizations also use. So the stateful firewall is also like this. And then we also have application level firewall. And this application level firewall is just there to protect applications. So what users and applications actually interact. This, well, let's say a simple example is a web application firewall, where we have this particular firewall, but this firewall is not protecting a computer. They're not protecting, let's say, the network. It is protecting this particular application. So we have put this firewall to protect an application or to protect this particular software that we have. So any request going from internet to the software will pass through this particular application level firewall. And based on what people send, this application firewall will inspect everything. So this application firewall acts like a betweener between what users will send and the internet looking at the app. So if you have a website and there's an application, web application firewall, the website will be there. But when people make a request or when people come to the website and says, I want to watch a movie, that request will pass through the firewall before it goes to the website, where the website will say, okay, so if somebody is making a bad request that I want to get access to somebody's password from this particular website, the web application firewall, based on certain things, will say, no, we will not allow this particular request to even go to the website and the web server for it to process everything itself. And that is actually a web application firewall. Then we also have modern firewalls that a lot of organizations also use. This is the next generation firewall, where it is a single firewall, but it has a lot of activities. It has different things all together. This particular next gen firewall is not even concentrated or doesn't even only look at traffic going in and out. It would inspect where this particular traffic is. It would look at or would see if, let's say, we have allowed this particular person to send me traffic. So let's say I've allowed my friend, because my friend is part of my organization. I've allowed my friend to send me, a message or anything. But then, regardless of whether we've allowed this person, the next gen firewall will still check, will still look at, even though we've allowed this person to come or to send message or to send a request, is this message correct? Is this message what the person should send? So a next-gen firewall has this capability of working or doing things like, let's say, anti-malware. If something that the person is sending is a virus, regardless of who we've allowed, the ports we've allowed, the protocol we've allowed, if this thing that the person is sending is a virus, the next-gen firewall can say no. Will not allow this thing to enter, because when we brought everything down and we checked, that packet that's being sent over the network is a virus. It would also do the job of IDS or IPS and different things. That is a next gen firewall. It is mostly used in a lot of organizations, enterprise environments, where they want one central thing that controls everything. They don't want to put different things together. They have one firewall that controls everything together. Fortinet has this particular system. Cisco also have this particular next-gen firewall, and Palo Alto. So when these people that I'm talking about, these people are, let's say, the leaders when we are talking about next-gen firewall. So Sophos, Cisco, Fortinet, and then Palo Alto. These are like the companies where, let's say, they are in charge or they are top when we are talking about firewalls. Okay. Now, this is all that we have. Now, let's actually look at a simple demonstration about firewall. Now, when you have your computer, right, you see a Windows Defender firewall. So you see Windows Defender firewall. That is operating system level firewall. Windows Defender firewall. So when you go to Windows Defender firewall, you could do all sorts of things on the Windows Defender firewall. Let's say Windows Defender firewall, you could block, you could allow, and all these things actually look at network coming inside your Windows Defender or your Windows system. So this is looking at traffic going from outside or wherever to your computer. You see, we also have some endpoint protection tools that also act as a firewall, like Symantec. Symantec is traditionally an anti-malware software. Symantec also has the capability of acting as a firewall. Okay, so let's open Symantec and let's look at Symantec as a firewall from the console. So Symantec can also protect systems and also act as a firewall. Anything actually coming through, Symantec will see this and then look at, okay, whatever that is going through, we don't want that. Or based on certain behavior, Symantec would block it, or Symantec would allow it, or so on and so forth. So Symantec can also work as a firewall. So you see the Symantec firewall here, where you can enable this particular Symantec firewall. And these are some few settings that you can do, right? And with Symantec firewall, they have other features like Smart DNS, Smart DHCP, and all those things where they have certain things built in where Symantec can, be looking at all these things that happen when you talk about firewall, things coming in and out. So on a normal computer, when you actually buy a computer without even installing anything, your firewall is Windows Defender firewall. Now, Windows Defender firewall, if you don't set things up, it will mostly look at, or it mostly come with things that have been preset by the Windows. So if you don't have anything there to add or block, it will just come with what the Windows says it should come. That is actually what it will come with, right? Now, with the Windows Defender firewall, you have to understand that every firewall, we look at inbound and outbound. So things coming from the inside and things going from the outside. And I told you already that firewall actually look at rules. So I'm talking about this is a basic Windows firewall, right? It will look at rules. It will look at things going to your laptop and things going from your laptop. So if you want to block certain things on your laptop, you could go to new rule and then you could block based on a port, based on a program, or based on something that you customally define. So that will be the rule type for this particular thing, right? So this is an operating system level firewall, Windows Defender firewall. Okay. Now, we also have firewalls for Linux. Linux also have their own Defender or a version of Windows Defender firewall. So we also have Linux system firewall called, or the one that we mostly know is the UFW. The UFW is the uncomplicated firewall. But before we even go to Linux firewall, let's look at this particular type of firewall, an application level firewall called Glasswire. So Glasswire is also an application level firewall that looks at things coming from the internet to your application and tracks them out. So if you have Glasswire, and Glasswire has a free version and a paid version, you could use Glasswire to check anything going through your computer. You see, to see visibility, look at traffic coming from apps or traffic going to apps on your computer. So if, let's say, I come in here and I see Microsoft Teams, I could know the traffic going from Teams to the outside. And if I see that, I can decide to block it. The moment I block, let's say, Microsoft Teams, it means that this call would end because I am shutting down traffic between the internet and Microsoft Teams. This is sitting in the middle of the application and the internet. So I have all apps that I've been using and what is happening on those particular apps. So this is what Glasswire. So on the left-hand side there, you can see all the apps that I'm using right now, my Microsoft Teams, my VPN, and all those things are here. And this is talking about where these applications are connecting to where. So if you look at these places, you can see that my Microsoft Teams is connecting to a host in South Africa, and the IP address has been provided for you. My VPN is connecting to a host in the USA. So it will look at where you are connecting or where traffic is going to which particular location, and then the countries are also written down here for you to also understand. This is application level firewall. Application level firewall. This is Glasswire application level firewall. Okay, very, 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 very nice and simple. It also has a feature where you could add Virus Total. Virus Total being an online engine that we use to search for threats, or it is a threat intelligence software or threat intelligence web application that we use to find out whether things are bad or not, whether links are bad or not, whether IP addresses are bad or not. So because Glasswire looks at what your apps are doing, who they are talking to, or the servers that are facilitating, or the servers that are powering these particular apps, Virus Total is also in the back scanning every connection based on its engine to check and see if the places that these apps are talking to are bad or not. You see what it is? So everything. So if Microsoft Teams is talking to a server in the US, Virus Total will check the server and see, based on its engine, is this server bad or not. So all the things you see here, 0 out of 71, 0 out of 71, it just means that Virus Total has scanned it, and then Virus Total couldn't see anything about it, and it is 0 out of 72 engines. And most of you who are familiar with Virus Total already, you know that when you scan something, it comes like this: 0 out of that, 0 out of that, or 2 out of this. And you know that when it turns red, or when you even see, let's say, 1 out of 72, then you know that maybe there might be something wrong. You can go ahead and check, like this one, where it is showing that 1 out of 72. You can go in there and look at why is it saying 1 out of 72. And you could go in there and then you can inspect. Okay. And that is also one simple thing about this being an application level firewall. Okay. Now, we have this firewall that works at a network level firewall, and that is pfSense. So pfSense also works as an application, as a network level firewall. And pfSense can also be an appliance or can also be a software. Mostly, Fortinet is the organization who manufactured pfSense or who is behind pfSense, right? And then you can have or you can order Fortinet device and it will come with pfSense installed or will come with a different version of Fortinet installed. But they also have that particular operating system that you would have run on an appliance, and you can use that to create a virtual machine where you could connect everything through your virtual machine, and that will be looking at network traffic. So Glassfire is looking at application traffic. This is looking at what a network traffic itself. Now, pfSense can also be used as an enterprise network firewall. And this is an example of that. And this is looking at records of all things going in and out from different IP addresses that are connected to this particular firewall. And you could come here and make a simple rule, and then you could block or you could allow. You see, that is what pfSense is all about. This is a network firewall. So before anything even comes to this particular operating system, pfSense will be sitting on the network to check, as compared to Glassfire, where it will allow the traffic to come. It is looking at traffic going between applications itself, apps itself, not network itself. Okay, now that is also one. And like I said that Linux also has this their own operating level firewall called the UFW. So the UFW also acts like Windows Defender firewall, but can do more than that. So let's see if we already have UFW installed on this particular firewall, on this particular Linux system. So let's check. Okay, I don't have this particular UFL, so let me just install it on the system and then look at how it works, or the basic things that we can do to set up things on this particular Linux machine. And you have to know that this Linux machine is connected to a firewall. It's connected to a network firewall. That is the pfSense network firewall. And because this actually mostly it will check, so every request will pass through this particular network firewall. That is actually what it is. So most of the things in here, and even if it takes a while, it is passing through a network firewall, right? But this particular UFW, it is a Linux-based operation level firewall. That's what you have to understand. Network firewall will look at network traffic coming in and out through the network, going to individual PCs or individual computers. But what we have on the computers mostly must be on the computers, or will check after the traffic has gone to the computers. That is actually what it will do. So let's see if we can install UFW like this. Then with Linux, it is mostly simple commands. If you know what you want to install, these simple commands, you will use them to install these things. And when this installation is happening or whatever is going on, it would still pass through the network firewall. If the network firewall sees this particular thing and says, nah, we are good, or where this traffic is coming from, and says, we don't actually want this particular thing, we are not interested in this particular thing, the network firewall will not allow me. That is why it was unable to fetch all those things, because Linux actually used port 80 being HTTP, as its repository to download things. So if you look at here, there's HTTP, HTTP. It's not like all HTTP traffic are bad. Linus in default actually uses what HTTP in downloading or in accessing its repository so that downloads are faster. Because mostly with HTTPS, there's encryption and decryption, encryption and decryption. But with repository downloads, you just download it as soon as possible. It comes and then you are good to go. So Linus mostly use these things. And because this particular Linus system is connected to a pfSense firewall, it will not allow it to actually happen unless I go inside or configure things or I force the Linus to use HTTPS. That can also be a solution around it. Or if I take it out of the firewall, then that also can also happen. It will allow it to happen or to run without any issue. So far, we've looked at two or different firewalls with Glasswire as an application level firewall. We've also looked at, let's say, Windows Defender Firewall. That one we are familiar with it already. It is on our computer. And if you want to block a person, an IP address, or block a website's IP, or a hacker's IP, or a port, you could go to Windows Defender Firewall and just do that simple. Then we also have industry firewalls like this. pfSense, you could go in here and then block a firewall by creating rules or block something by creating rules. So WAN and LAN, so local network and wide area network. So if you want to block anything, you could add this and then you choose your interface and IP4 address, the protocol, TCP, UDP, ICN, all the things that you want to block. You see them here. And then when you come down, you choose the particular ports. So if you chose a port and you want to block a port, so if you want to block a TCP port or UDP port or anything, it can even be an ICMP echo. And you could choose from all these ICMP types. When I say ICMP, the basic understanding of ICMP is when somebody wants to find out you are online or not, they can just ping your computer. So ping is an ICMP echo. I can ping 8.8.8. This is Google service. So if I ping Google service, I know that Google servers are active. You can block all these things with these firewalls. And when you block an ICMP echo or ICMP, if somebody sends you a ping trying to, let's say, find out whether you're active or not, the person will not see anything. Or that particular request will be dropped. You see, that all those things can happen. So based on these things, at least we now know that firewalls are very, very important. If you have a network firewall in your organization, okay. If you don't, you can use the firewall like Windows Defender Firewall to block certain things or to block certain peoples or to close certain ports. Right? If there are some ports that you don't like, you don't want them open, what will you do? You close them. There are certain ports out there that you shouldn't keep them open. You see, you can block all those ports and then allow only the you need. Let's say port 80, port 443, maybe if you're interested in port 22 to fine or port 21 to fine. And definitely port 53 will also be active for DNS. Aside that, you could, block everything and leave only a handful until maybe when you are in need of them, and then you allow them, or only allow the ones the systems are using. And with those ones, you just allow them. And that is easier and you don't have any problem with that. So today, or right now, we are looking at ports. So we are looking at firewall, and then we are bringing our firewall lecture to a close. But at the end of the day, we have understood or we've gotten knowledge about what a firewall is. Firewall will look at all traffic coming in based on where it is put, and then it will look at based on the rules you set. So without rules, firewalls will be mostly inactive, mostly except the next gen firewalls or maybe those application level firewalls, right? But then when you talk about a firewall without rules, if you don't set rules, mostly a firewall will be inactive. If you don't allow to tune things, set things up, allow IPs, block IPs, accept this range of IPs, this and that, firewalls will just be looking at you as compared to other things that would, when the moment you install them, it will run, like let's say an anti-malware. The moment you install an anti-malware, it is there. An antivirus, it is there. If you are downloading something and it's a virus, it would check, it would block you or would delete it without you even going in and doing things. It will just do its job. It's a firewall. It has the ability for you to configure things, for you to add things up. It is what you like and what you put there. So if you receive news that bad hackers or attackers are doing this or that, it is a firewall that will add as an enforcer that based on your threat intelligence, you realize that 50 these IP addresses are bad or they are causing harm to people's network. So now let's enforce it. So the firewall would enforce it where you put these IP addresses inside the firewall and the firewall would enforce them that whenever anybody coming from this IP comes to my network, then I'm not allowing it. And this is where we are ending today's class or today's seminar about firewalls. Okay. Any questions about what we've done so far? Then we'll bring this to a close. Or anything somebody would like to add, then we bring this firewall to a close. All right, okay. If there are no questions, then thank you guys for joining. And with applications like Glasswire, you could go online